I'm Larry Williams, the Director of CARMA, the Consortium for the Advancement of Research Methods and Analysis. And it's my pleasure to welcome you to another version of a CARMA Quick Chat. This is the format in which we like to have brief conversation, catch up, learn from people who are contributing to CARMA. And today we're very excited to have Mikko joining us because he is giving a CARMA Webcast lecture next Friday on October the 6th. Mikko is a associate professor of entrepreneurship at Jyväskylä University and has been very active in publishing research methods on research methods topics, several outlets. So Mikko, we're very happy to have you join us for this chat, and we're very much excited to have your webcast for us next week. So I like to start out with chatting with people by saying, what is it that got you interested in research methods? I'm always surprised at the diverse, varied ways that people that come together with common interests. How did it happen with you?
Okay, this is a question that I could spend a lot of time talking about, but let's try to summarize the main points. I've always liked math, and then I went to study industrial management, and I figured that my math skills are going to be wasted there because it was kind of soft compared to, for example, physics and math that some of my friends studied. But when I got to the doctoral level, I decided that I'll do quantitative research, and therefore my math skills will not go to waste. And I wrote my first paper, and I was looking at what other people were using, and I found people using this thing called LISREL. And I managed to get a copy of LISREL from the statistics department, and I somehow managed to get some results out of the software. I think LISREL is horrible to use, but I got some statistics out, and I sent the paper to a conference, and then the reviews come back. And one of the reviewers says that this paper should not be accepted. The author clearly does not know what he is doing, and that kind of got. I
think I had that same reviewer on one of my papers.
Yeah, but I really started thinking. Yeah, I just got some numbers out from the software. I have no idea how the numbers came to be, so I decided that I should probably read something before I tried to publish my next quantitative paper. And then I took Cohen's regression book, which I thought was pretty advanced at that time. It felt really hard to read, but then I kind of got interested in it, and I started doing and learning and reading. And so that is how I got interested into learning about methods. And then how I got interested in doing methods is also an interesting story. I was working with this professor who is a qualitative researcher, and he was working on a paper with some survey data, and they had a method variance problem, and no one of that author team knew how to handle it. And they knew that I had just taken a course on structural equation modeling and asked if I could take a look at their data. And the paper was using something called PLS, which I knew nothing about. And then I happened to know a guy who did math, and then we started to think, okay, so how do we do method factors with this technique? We figured out a way, but we figured also out that PLS technique really didn't do what people were thinking that it does. And I decided to write a conference paper about it, that look, guys, this technique is not as good as you think. And then I published that in a big conference on information systems. And people just dismissed the idea. So they would say, yeah, your data looks good, but we don't buy your claim. We are using this technique and we like it, so go away. Then I figured that, okay, I need to write a paper to a journal. And I got to know another guy called Jörg Everman, who also wrote a critical paper about that technique in the same conference. And then we got together and we wrote my first ORM paper. And then that got me started. So that's kind of like a coincidence. You find something that you don't really know how it works, and then you want to understand how it works, and then you realize that there's a lot of things that people don't know about this technique. Yeah. And I guess that is something that drives me now, is that we use techniques in a suboptimal way or in a way that comes from tradition instead of coming from methodological grounds, and then I write a paper about it. Yeah,
So,
that's
so
how it is.
last week I did an interview with your somebody who'll be presenting a webcast paper next week also, and it was the same story with him. It began with trying to understand something and his results. So during that time, was there any really important event that when you look back, you really had an impact on shaping your interest or your career? I mean, was it that publication, or was it the early faculty member that in your training that inspired you?
No, I'm actually self-taught, so I wasn't trained by anyone. Yeah, well, there's one doctoral course that I would like to mention, but let's talk about that in a moment. It was the first ORM paper, so I had my dissertation was not done at that point, and I had one ORM paper, and then I had a spin-off paper idea, and then I had a bunch of data collected for some other purpose, and then I had to make a choice that do I do an empirical dissertation, or do I build my thesis around the ORM paper and then some other related work? So I've always had these two tracks, like the empirical track, the methods track, and then I decided that I will get a better dissertation by writing about methods than doing empirical stuff. And then we got Jeff Edwards to be my opponent.
Yeah.
And he was a very motivating guy. He got to me more interested into methods, and he got me get to know some people who work in the area. So yeah, that's the one paper that I happened to publish. That's how I got started. And I guess that's also how many people get started. They get an idea, they write something, and then they realize that, yeah, there could be a follow-up to this paper. And then that's kind of how you get started.
Yeah. Well, and having some success early on can certainly be rewarding and help drive that future interest. And yeah, Jeff is a dear friend and a longtime Karma contributor, and I've seen that he's had that impact on many people that I've come to encounter. So you do a lot of work with doctoral students or junior colleagues who aren't as advanced as you are. Do you feel like that there is any one particular topic in the area of statistics or data analysis that they find most confusing or misunderstand the most?
I think that's the hardest question that you had on your list of questions. I could name two things. One thing is that came to my mind when I was at the Meet the Experts session at AOM this summer, and there was a guy who was presenting his analysis to me, and then I was telling him that your analysis really doesn't work. So if you apply that analysis in that situation, it'll never reject an incorrect model. And then he said, well, isn't that great? And well, no, the point of analysis is not to get results that look good, it's to get the results that look correct. And this is kind of like a misconception that when your chi-square rejection model or your p-value for regression coefficient is non-significant, it doesn't mean that the p-value or the chi-square is incorrect. That's a finding. Your theory might not work. And that is something that people start to fix somehow, but that's not the thing to do. So that's the first thing. And the second source of confusion is that when I have students coming to my class, I typically run two seminars on our introductory course to research methods, and then I run my quantitative methods course for half a year. And then I have 1 year course for advanced quantitative analysis. But after the first half a year course, in the beginning of the course, they look at an AMJ paper and they look that this is a perfect thing. So I could never make anything this good. And after the course, they start to realize that even the best papers, they are not perfect. So there are little mistakes, little things that you could do better. And understanding that no research is perfect, and understanding when imperfection is not something that will kill your paper. That is also another thing that people struggle with. So how do I know that my paper is good enough?
Yeah.
Which of all the hundreds of things that can go wrong should I really pay attention to? And that's another hard thing.
Yeah. Well, it's those are interesting lessons. When I teach my methods courses, I try to reinforce for them that in spite of the excitement that they have for the statistical evidence in support of their models, that they never really prove that they've got the model, and that they have to be really vigilant in pursuing alternative models. And of course, that's hard to do when you've invested in your theory and your data sends you a signal that says that it's good. You want to just stop right there. So you mentioned so far in the conversation that a couple of the different areas of methods that you've worked in as your career has evolved. Is there any one that you would say is your favorite?
About topics, I'm not sure if I have any favorite topics. I like some papers better than others. Most of my work relates to modeling somehow. So there's always a model, even if my paper about discriminant validity that this karma seminar will be about, even that is a modeling paper to some extent, even though we talk a lot about the conceptual side as well.
Mm-hmm.
But in terms of what I like the best, I think it's more relates to how the review process has gone instead of what is the topic of the paper. Mm-hmm. So I really like it when I have reviewers who get the point of the paper on the first round and say that this should be accepted, but still they push for one or two more rounds of edits to make it even better. Yeah. And two of the better examples of this process working out is my paper on transformations and nonlinear models. Yep. That I got the best paper award for last year in ORM. Yep. And then this discriminant validity papers. Both papers, the reviewers said that they're really strong to start with, and then you go 2 revisions more, so it's accepted from the 3rd round, and that really makes the paper better and really pushes you to make it as good as it can be. Yeah, and I particularly remember the discriminant validity paper. The editor says that, I'm going to accept the paper, but you have to make it 10 pages shorter. And that was painful, but in the end, it was really rewarding. Yeah. Just try to cut it to the essence, like eliminate all unnecessary things. It just made the paper so much better. So no favorite topics. I'm kind of like generalist as far as it has a model. If a paper doesn't have a model, then that's not my paper. But yeah, I think the review process is what makes a paper enjoyable to write. Yeah, well, it certainly is easier to push for through those revisions when you've gotten those strong signals early on. And I don't know if it's been like this for you, but for me, there's been many times where I've gotten that request to cut it down, and I'm so offended by it, and I say, there's no way that I can do this, and I do it, and it ends up it's much tighter. Yeah. I think a lot of us have, at least for me, kind of a natural style of going overboard and being redundant with explanations, and that's good up to a point, but there's a time that can slow things down. So, hey, how did you get interested? Your webcast lectures going to be on one of your recent ORM papers on convergent and discriminant validity. And so how was it that you got interested in that topic? And can you give us a preview of what you're going to say? Okay. Yeah, I got interested in that topic. That is a coincidence. So I had written a paper about PLS to RM, and I discussed discriminant validity there. And then I got a cold call or an email from this Korean guy called Joe. I don't know how to pronounce his first name. And he asked if he could get my R code so he could use it in some simulations that he wanted to run. So he was working on a paper idea on discriminant validity. And then I gave him the code, and then a month later, he sent me an email telling that he can't really figure out how to do the simulation. So would I be willing to help him to become a co-author? And he had just won the Best Paper Award for ORM in 2015. This was around that time when we got started, 2016, something like that. And then I decided that, yeah, this is a guy who knows his stuff. He knows how to write papers. And I'm in. So I just had defended my dissertation 2 years ago. So senior people want to work with me, great. And then we started working on the paper. And at some point we decided that I've actually done more work than he had. And then then I was the first author when we submitted the ORM. And this is an interesting paper because I never met the guy. And I never talked with Joe or phone either. So we wrote the paper by email. I don't think that we even had any file sharing service. We just sent files back and forth. So for all I know, this guy could be just an AI who writes papers.
Well, that's something we'll have to worry about more in the future. So
yeah,
what will be some of the main points that'll come out in your lecture then?
Yeah, I will start by explaining what is discriminant validity and what is convergent validity. And then I will talk about how convergent validity differs from reliability. This is something that I've been thinking a lot, and I haven't seen a very good explanation. Typically, when two variables correlate highly, if they're supposed to measure the same thing, we could say that that's evidence of discriminant convergent validity, or that's evidence of reliability. So what's the difference? And I think I figured that out. So I will tell you what I think. And then I have to take a look at my notes. And then I'll talk about when including these concepts and showing statistics to support these two kinds of validities or two kinds of validity evidence would be useful. I don't think that every paper should address convergent validity and discriminant validity. They are for specific purposes, and I'll talk about those purposes. Then I'll talk a bit about the different statistical approaches, particularly for assessing discriminant validity. And then I'll conclude with explaining what kind of workflow we recommend with Joe on when dealing with these concepts, and how you could report your results about convergent and discriminant validity in a paper.
Yeah.
So that's 5 things: introducing the concepts, when would you want to use them, how do you go about it, and how do you report it?
Those, first of all, let me say it's one of my favorite papers, and I use it in the SEM class that I teach. So for the audience, I encourage you to come and join us. I should have said at the beginning that this Karma Webcast lecture that Mikko will be giving is offered as part of our Karma Webcast lecture series for institutional Karma members. And you can find out more information about the webcast and all that we do on the Karma website. And you can find the URL in the materials related to this. And also, we're very excited because this is the first year that we are switching up the start times on some of our lectures. And so Mikko's will be starting at 9 a.m. Eastern time in the US, rather than our usual later in the day start. And we're doing that to help make it more readily available to people in the Europe in related areas, where it will be 2 p.m. London time. So again, visit the Karma website and you can learn more about what we do. And I encourage you to come join us for the webcast. Mikko, it was great catching up with you. Thanks so much. I'll see you next week for your webcast.
Yeah, I'm happy to join in, and always pleasure to give a talk at Karma.
Yeah, and I appreciate you wearing your t-shirt. It's a good look.
Yeah. Thank you.
Thanks.